Alright, so here we have part three. We're going to counter drill some holes. Right here I'm showing you that I've selected an end mill that has a long enough length of cut to make it across the entire 1 inch surface. That's the saw cut surface. Oh, and I just did a pan shot showing you that we're using the same style of vise stop that we're building, and I've extended the contact point really far so I can hang out on the right side of the vise, and my contact point is in the center of the block, which is a great place. I've lowered the spindle down against the spindle stop, and now I'm raising the table up. Um, you know, I start most of my setups this way in a milling machine because I can always move away from the spindle stop, and when I return, it'll repeat within a few thousandths of accuracy, if not, a negligible error of less than a thousandths. Every machine's going to vary. So I'm just going to touch off, come to bring the cutter to our side of the part, and then dial over. Actually, we might be able to see up there on the readout screen how much I dial over. We're at 246. So about, what was that, 12 thousandths? That's a conventional cut. And then I'm going to take a climb cut back. Even though that small cut wouldn't have had any deflection, this little climb spring cut here, it does ensure that if there were any deflection, that now I should have a square to my top surface cut. And that's what I like. I like being able to pull up the spindle away from the stop. Now, off camera, here, I show you the burr, and off camera I deburr it and I cut through the film. A lot of times I see students ignore burrs like that, and then they set their part of the vise and they machine, and later on they're baffled at why they have 10 thousandths taper on a face milled surface and things like that. So everything counts. Your setups have to be good. Take time to burr your parts. Make sure the chips are all cleaned out from underneath your setup. Now, right here at this point, I'm still using regular thickness parallels. You can see them under my part. You'll see in a little bit I'm going to switch to the ultra thin parallels. Now this first pass, so I moved the camera, unfortunately, and we can't see what I dialed. I'm going to guess I dialed over 20 or 30 thousandths. And I continue to do my conventional cut and then a spring cut return with a climb cut. So I sneak a little measurement here. And I think I recorrected right there to show you the camera that we have 35 thousandths to go. Now when I watch this, I think I should have been feeding a little harder, and that's where the squeaking is coming from that you can hear. It is a heavier cut, slightly heavier cut than the last two cuts, but I want to, I just look at that and I think, yeah, why was I feeding the handle so slow? Because I'm manual feeding on this. I don't have a power feed on this machine. And then I'll take another measurement and show the camera that we got good size within 1/1000th of an inch. So layout, I just want to include this so you can see. It's always a good idea to make your layout lines. They'll prevent you from putting a hole in the wrong location. And a part like this that we're going to be rolling around in the vise, if we want to do it efficiently, these layout lines are going to really save you. So we touched off, went up a half of a 500 thousandths, and then we're going to mark two sides of the part. So now we know the center line of the part. And then I run back down and touch off on the table, make sure everything is still where it should be. I come up 190 thousandths. That's going to be our smaller 1024 tapped hole. Take a peek over at the print, mark the other side. And then the 3/4 inch reamed hole, it's dimensioned off the opposite side of the part, or if it would have been an absolute dimension from the same datum side of the part, I would have raised the scribe lines higher, the height gauge higher. Alright, so I got my marks, kind of glance over at the print, check your layouts with a ruler. Every now and then we make silly mistakes. So now, here I am, I'm showing off the little, spring divider and the thin parallels, because the part's an inch thick, the reamed hole is 3/4. So if I have two parallels that are 1/8 inch, that equals 1/4. And if I try to fit a 3/4 inch reamer in between a 3/4 inch gap, I end up probably making contact with my parallels with the reamer. So always think ahead. Now the edge finding here, I actually set up 2 cameras, but I lost the footage off one of them. But I'm just going to come against the back wall of the vise till the contact point jumps. Then I'm going to 0 the readout in the y-axis. I'll lift the spindle up, and I'll move 0.100 thousandths more in that same direction. So then the center line of my spindle is over the back jaw edge. Now I move down my 1/2 inch, and I'm going to find the X0 on the side of the part that my contact for my stop is where it's located. So I come over and it jumps. I hit 0 up there in X. You can see the shadows. And then I move over 0.1 and I re-zero it. And then I do something I always encourage my students to do. I shut off the spindle, just center it by eye, and then is it half on and half off? If the answer is yes, you probably did it right. Then I move over my 0.190 on the readout, and I'm going to throw my center drill in. Just like the last part, I'm only going to center drill the tip section of the center drill. It's going to locate the drill bit's web and chisel edge to the point where it will not be able to escape and give me a out of position hole. And generally speaking, I center drill or spot drill just about every hole location. Of course, if something really doesn't matter and you know what it is, then you can just go ahead and drill holes. But usually you want to know where the hole is going to end up precisely. This will increase your chances of having the desired results. Now, I come back over here, and this is, actually I just flipped the part around first. I was getting ahead of myself. But this is a nice thing about if I machine the block to 2.500 and it's an accurate length, I can just roll my, or re-index my part against the stop, and everything's going to line up within a fairly small margin of error. And that's what I'm talking about. The web, the chisel edge of the drill bit, it's not going to escape that spot drill mark. And like I talked about in the last video, if I go down deeper, it's just harder on the drill bit when it enters the hole. Alright, so I have my number 7 drill bit, and then I have my drill bit for the tap size of the 1024. I'm going to drill all the way through the part with the tap drill size. Then I'm going to counter drill halfway through the part with that number 7. Do not drill all the way through the part with the number 7. That's a clearance drill. If you do that, well, you're going to lose some points on your part. There is, we can step this up to the next size, but let's just make it to the print instead. So, you know, you'll see I'm peck drilling, and in the end here, I do end up with some chips that are wrapped around the drill, but I don't use my finger to knock them off the drill bit. You know, you always want to, usually I use a 6-inch ruler, but this time I use the handle, the chuck wrench handle. Oh, actually maybe that's on the next side. So, and I didn't have to worry about the burr that was coming off the back of the back side of the hole because it's hanging out of the part over there on the right side. If I was clamping across it, I would have briefly filed that surface or spun a countersink with just my fingers to break the edge. There's lots of things you can do. Alright, well maybe I didn't include that part of the footage where I knocked the chip off the drill, but it was there. Okay, so here's what I'm about to do. I'm going to lower the knee, and then simultaneously I'm going to lower the spindle down against the spindle stop. Then I'm going to turn on the spindle, and I'm going to raise the knee to where the full diameter is flush even with the top of the part. So I'm against the spindle stop. Now I'm going to turn the spindle, I'm going to raise the knee to where the full size diameter of the drill bit makes its way to the top surface of the part. Then I'm going to lift the spindle away from the stop. Now when I'm away from the stop, from that point, whatever distance I raise the knee will be the distance my drill bit will go into the part when I drill back down to the spindle stop. So right here, the drill bit was level, I raised it up. Now I'm going to lift the knee. If you look really close, you can see I'm raising it 500 thousandths. So now when I return the spindle to the spindle stop, the drill will be 0.500 thousandths deeper than it was. I think I made that clear. Now when I'm drilling into this counter drilled hole, I have a slight amount of tension on the coil lock, and that's going to help me feed at a nice steady consistent rate, because if it's just loose and there's no tension, it'll be easy to overfeed the drill bit. Alright, so it looks like that's where I finally knocked the chips away. And again, you know, I really messed up the filming of this, but I take the part out, clean it up, and I put it back in the spindle. But then before I drilled, for some reason I stopped recording. So you're not going to see me finish this hole. This is actually going to wrap up the end of the video. But I think you get the point, and just make sure you don't drill all the way through with the clearance drill bit.